All right, should be recording. Thank you everyone for joining today. Hope you're excited. This is a co-sponsored, co-hosted event between the Foster Marketing Association and the Data and Analytics Club. So the reason we are even hosting this workshop series, it is a 3-part series, as you might know, is to basically introduce everyone to SQL, starting from the basics up to the more advanced queries if you're feeling up to it by that point. And by after the first and second sessions, I really think everyone should be. But the reason we put this on is because we heard from a lot of people that there's more interest in knowing SQL and other data and analytics based skills, especially because as you're all heading into either your internships or your first post-MBA full-time job, that we've heard from alumni, this is more and more proving to be a useful skill or like essential skill for some jobs that are out there. So we wanted to host this to build up that skill set for all of you. Quick plug is that for those of you who aren't already in the Data and Analytics Club, or maybe not even the Foster Marketing Association, for people who haven't signed up yet, please go sign up for those. Go to the MBAA store, sign up for that. You don't have to do it now, but maybe later, think about it. And then for those of you who are interested in getting the event recording after, it'll be posted to the Data and Analytics Club Slack channel. Evening MBA students, those of you who are here, welcome. You'll be added as a guest to that channel if you do click that link to join. So thank you everyone for joining. Without further ado, I'm going to introduce our wonderful speaker, Kevin Townsend. He told me not to make a big deal about this, so I'm not going to go on and ramble too much about him, but I remember him saying that he was kind of a big deal over at Amazon as the SQL guy who knew I don't know, just was a wizard with SQL. I hope I'm not over exaggerating that part, but Kevin, he's great. I'm really excited. So he is your first speaker for today. Take it away, Kevin.
Thanks, Christine, and thanks for embarrassing me. But it is my pleasure to be here today, and I'm glad to see that there's so much excitement to learn about SQL. It's something I enjoy doing in my professional career, and I think it'll be the same for a lot of you as well. So without further introduction, let's just jump into it. So yeah, as Christine said, the Data and Analytics Club is putting on this little shindig, but we're also doing it in association with the Foster Marketing Association. So it's great to see a couple of clubs coming together on such a cool initiative. So why should an MBA learn SQL? There's several reasons. One is to be able to utilize data to make the best decisions possible. Obviously, companies today have more data than ever before, and it's often not clear what data you need to use, how to get it, and having SQL skills allows you to kind of dive into their vast databases and get the best data possible for the best decisions possible. It allows you to be nimble and flexible. For a lot of you who especially work in kind of the big tech companies, there's probably going to be a data team whose job it is to help you as a business person kind of pull the data you need. But a lot of the times, they run on these sprint cycles, which could be 2 weeks long. And so when you submit a request to them, then they've got to prioritize it, then they've got to execute on it. And, it could be a matter of weeks before you get the data that you actually want. And if it's kind of a simple query, it doesn't, it's in your best interest to just kind of spend a half hour punching it out yourself and getting the data you need the day of rather than waiting 2 weeks, because the reality is most likely the data team is going to be swamped with requests. It's relatively easy to learn. Compared to other programming language, it's fairly straightforward. And when you get into kind of the more nuanced stuff, it can get more complex. But for the basics that we'll be going over in these 3 series, it's easier to pick up than a more complex programming language. Even if you're not writing your own queries yourself, it's incredibly useful to be able to troubleshoot the queries that are written by others or maybe by your data team, so that if you do have a problem, you don't need to just be what's going on, and wait for 2 weeks for somebody to get back to you. You can look at it right then and there, see what's going on, and identify the issue and maybe implement the fix. And then, as Christine kind of mentioned, you become the go-to person. I found that this was really beneficial for me at Amazon because one, it's a lot easier to ask somebody else to do a favor for you if you've been doing favors for them. You help your team excel, and then when it comes time for 360 review season, it's a lot easier to ask somebody who you've been helping out throughout the year with little 15-minute help sessions to kind of give you a good review when you've been kind of instrumental to them. And as we go on to the next slide here, I just want to point out that if you do have any questions at any time, go ahead and just raise your hand. I'll see that pop up on my screen, and I'll make sure to stop at the end of each slide and give people a chance to get their questions answered. But if there's no questions at this point, let's keep going. So what is SQL? Kind of talked about it a little bit, but it's a programming language for managing data in a relational database. So there's things that we as kind of an MBA coming out of an MBA program will be doing, and that's kind of on the right-hand side, where we're extracting raw data from a database, or we're extracting information from a database. And what I mean by extracting information will become kind of clear later on through some of the examples. But there's also things as MBAs, which some of you might be doing, but it's kind of more unlikely that these are tasks that we will be handling, which are inserting new data into a database, organizing that data within a database to have it be the most convenient form, or managing data flows and updates. And what I mean by that last part is, if a customer places an order on a website, the process of getting that like raw data from the actual order into a database itself in an automated fashion. And those things on the left-hand side are usually handled by a data team and handled by data engineers within a data team. And so it's kind of useful to know how that process happens, but it's not things we'll be doing ourselves. And in the interest of time, it's not something we'll be going into during this session. We'll be focusing on those 2 bullet points on the right-hand side. All right, so very, very boiled down version of what a relational database is. I'm sure there are true, data engineers who would kind of look at this and throw a fit because it's really more complicated than this. But for you to kind of get the idea, essentially in a relational database, it's just a collection of tables that have like key identifiers that help you link them. So here is like a very simple example. We have 2 tables. One has on the top customer information. The one on the bottom has order information. And as you can see with those orange arrows labeled key, there are these things called key identifiers that help you link information on one table to another. And in this case, it's the customer ID. So while that table on the bottom doesn't have all the customer names and contact information, you can just look at that ID and link it back to the customer table. And actually making that link from one table to another is the subject of our second SQL workshop when we talk about joins. So we won't be doing that in this session, as we'll kind of be tackling the basics first. And now is also a great time to introduce the tool that we will be using to practice today. So I'm going to quickly flip over, and Christine actually shared a website that's called the W3 School. It's really, really great for, self-teaching, if that's your thing, to go in and kind of learn about some of the basics. But it also has this super cool SQL editor where you can actually try it out yourself. And it makes sense for us as a class to kind of use this tool because SQL isn't really kind of manifests itself in only one area. Several different companies all have their own SQL. So like Oracle, IBM, Amazon, they all have their own SQL languages and places where you can implement it. And while like they're all very, very similar and really only differ on the kind of the more nuanced areas and the more complex bits of it, It doesn't really make sense for us to kind of like help you install it in one area when most of you will be doing it in all different types of places. And so this is a great place to try it out. And just a quick overview of what this is. You write your SQL here, you run it there, and your results pop out here. Super nice. And it has the database here. We just talked about the database with all different types of tables. And so as we go through the examples and the try it yourself opportunities later, you're going to kind of need to explore some of these tables to find the information or the columns you need. And so right now, I'm just going to make sure that I post that in the chat. So when it does come time for you to do this later, you actually have that link.
Okay, we double.
Oh, you already did it. Oh,
No
you're on
problem.
top of it.
The more the better.
Cool. Well, let's get back into the slideshow then. If there's any questions, just feel free to raise your hand. All right, so now let's get into the basic syntax. And the flow that you see on this table is going to kind of be reproduced in several slides that I have going forward. And you can see here that on the top middle, I have a table. And the table name is customers. And just assume that this table only has 3 records, very, very simple. And then what we're doing here on the bottom left is we're actually feeding it some SQL code, and the SQL code is actually transforming that into our output here on the bottom right-hand side. So basic SQL has, at a minimum, 2 statements, a select statement and a from statement. You always need to tell it what you're trying to get and where you're trying to get it. If you don't, it's going to be confused and not know what you're trying to do. So at the simplest form here, what we're trying to do is we're trying to select the customer name. And you can actually see that here in the second column, customer name. That's what we want. And when we select something, it's always going to kind of refer to this column. Where are we selecting it from? Customers. Customers is the name of the table. So by telling it the name of the table, it knows where to get this information from. And you could see here, there's an output. It just returns all records, but only for the column customer name. So that's SQL at its most basic form. One last thing to point out is there's this semicolon right here at the end of the statement. That just tells the computer that that's the end of my statement and I'm done. Okay, so going forward, what we have here on the left-hand side is that same statement that I've already shown you, where we're selecting the customer name from the customers. But on the right-hand side, we actually have the exact same, SQL code, just in a fashion that looks a lot less clear. So there's a couple of things to point out. First, you can see with select, it's kind of jumbled in terms of uppercase and lower cases. SQL, when it looks for the select statement, is not going to care if you have it in uppercase or lowercase. It's just going to click that you have the word, the letters in the correct order. And then when it looks for the column name that you're trying to feed to it, it doesn't care how many spaces are in between the select statement and the name of the column. So here it's tabbed over, it's like 2 spaces away, but SQL is smart enough to know what you're trying to do. And then over here, it's more jumbled up, but SQL knows how to handle this. And then the semicolon, rather than being on a new line, is right after customers. But that colon can be, doesn't need to be spaced in any way. It can be right after the last letter, and it's smart enough to figure out that that is the end of the statement. Obviously, the left-hand side is easier to read than the right-hand side. And as we go forward, I'll make sure to show you good examples and bad examples, because as your queries get more complex and other people are reading your queries, it's much easier for them to follow along if you're making everything organized rather than if looks like some ugly soup. All right, let's keep going. So now we're going to make it just a little bit more complex. And rather than just selecting one column, we're going to actually select two columns. And the difference here is that we're still selecting the second column in the select statement, but we're selecting the two columns we want, customer name and city, by this comma. And this comma essentially says that we're still using the select statement, but now I'm giving you another item, which is city. And just the same as before, we have the same table as we saw before, but this time we have a second column that was returned. This time we see the customer's city that they live in or do business in. So that's fairly straightforward. But it's also worth pointing out that as you add more and more columns, it can kind of get a little bit harder to make out what's happening here. This is only 5 columns, but it starts looking kind of more like a jumbled mess. Whereas what you can do is you can add each new column to a new line. So I can identify, okay, here's the select statement, and the from statement starts down here, and all of these lines here are columns that I want to return. And you can put this comma at the end here. It's kind of a matter of your preference and what works for you, but just make sure that you're consistent so that when you're troubleshooting, you don't confuse yourself. Okay. So the last thing that I'll go over before we kind of get into the first try it yourself opportunity is selecting all columns. So to do that, we can use this the star. And what the star says is, I want you to return each and every column within this table. And this is nice if you have a column with more rows or more columns than you want to type out and separate with columns. And this technique is really useful, as you'll see in the next example in the next slide, when you don't really know what's in a column, or when you don't really know what's in a table, you can just do select star and it'll return everything in the table. So then you can see, okay, in the customers tables, what are the columns that are provided, and what does the data within each of those columns actually look like? So then you can go from there and figure out which columns you need to pull. Because if your manager or your business partner asks you, hey, Kevin, can you pull all the names, the contact names from our customers table? He or she is not going to give you the actual column name. They're going to give you the colloquial meaning of it. And so you've got to figure out what that actually is. So now let's go into our first example. And for this, we'll take about 5 minutes. There's 2 things for you to try. And once again, you're going to try it in that SQL editor that we pasted in the chat. And so first, just try to view all columns in the products table. So that's just trying out the select star method, and then try to extract the column from the products table that shows the product name and its cost. And so I'll pop this up here, but just a reminder, you can look at the left-hand side, find here the products table, and explore it and try entering code here to pull out what you need. So I think that what we settled on was just doing this as a main group, and you can kind of jump in and ask questions if you'd like, but we'll take kind of 5 minutes now, or you can take this opportunity to take a quick break if you like, and we'll kind of pick it up at 10:55 after you kind of had an opportunity to give this a try. And feel free to raise your hand and ask questions during this time. I'll be here.
Hey, Kevin, can I ask you a question?
Of course.
What SQL database were you using at Amazon?
Yeah, we started off by using Oracle SQL, and I just use like a tool called like SQL Workbench to pull from our like Oracle databases. But then we started shifting over to using Redshift, which
Mhm.
is Amazon's like SQL logic, because obviously Amazon wants to use their own thing. And so we kind of shifted over like in between kind of my tenure there. But like even switching from one to the other was like no problem at all. It's like very similar.
Yeah, we used Redash for ours, but it was connected to Redshift too.
Yeah, from my understanding, like a lot of the differences are just like on, I guess like how they like, I don't know, process the data, and like apparently Redshift does it faster or
Mhm.
better than like the Oracle version did. I didn't really notice a huge difference. I'm sure it matters if you're an actual data engineer, but for me as just somebody who was like pulling it, it was all the same.
As a follow-up question, are we going to talk about setting up like a SQL database here and like connecting it, or is that like kind of too?
That is I don't think that's part of the series.
Okay.
So if you already know like SQL and everything, it's kind of might be like boring for you. Because like a lot of people I think that were the kind of like the target audience of this is like people who just like have never used SQL before. So
Yeah, cool. Yeah, just curious.
yeah. And I've actually never set up a SQL database myself.
Yeah, I
So
feel
I
like it's
wouldn't
just
be a good instructor on how to do that. But I think the W3 school like does have like, I don't know, basic like tutorials on how to do some of those things, but I haven't tried that out yet. So
yeah, I feel like they're separate. Like usually it's like you were saying a data engineer or something, but
yeah,
I was just curious. Cool. Thank you.
yeah, of course. Okay. Well, I guess I'm going to start just trying out showing the solutions then. So essentially, the first question was viewing all columns from the products table. So we go to the products, and actually it does show you all of the columns already when you pull it up. But actually, it actually kind of has it here. You're just selecting the star like we showed before from the products table, and this has it in brackets. I'm not really sure why it does that. But if you just select products and run it, we get everything from the products table, kind of like the most basic type of query we could run. Now we want to extract all columns from the columns from the product table that show the product name and its cost. So examining the product table, we can see, okay, here's product name. And I'm lazy, so I'm just going to copy it. Also helps me reduce mistake. Copied in there. I like to make it nice and readable. So then I'm going to put my comma in, and I'm going to find its cost. Looks like it's actually price. So, kind of just intuit that, put in its price, run the SQL, and there you have it. So super simple. Anybody have questions on that? I promise we'll get a little bit more complex as we do some of the other examples going forward. Okay, so now that we've tackled that, let's move on. Where statements. So, we don't always just want to pull every single record from a column that we're pulling. Sometimes we want to actually filter it down based on certain attributes. So the customer attribute here that we actually have to filter down on is only finding our customers that actually live in a certain city. And in this case, that city is Mexico DF. So what we did is we added this new statement. So first we had the select, then we had the from, and now we have where. And what we did is we said, okay, I only want the customers' names who have the city. We can see city here refers to a column. that is equal to Mexico DF. And SQL goes through, and rather than before pulling each of the 3 records, it only pulled the 2 that matched our where statement condition, which was the correct city. So that's super powerful. They could be able to filter records within a database to kind of get only exactly what you need. And let's kind of dive into this just a bit more. So one thing that is worth pointing out is when we did this first example, we used a string. We used Mexico DF before, which had spaces, but here we're using Berlin. And Berlin is a data type known as a string, which is something that needs to be surrounded by quotation or single quotation marks, so that you're telling the SQL that this isn't a statement or a column or something else that I'm trying to pull. It's actually a string within a string that I'm trying to pull here, and not just a new column name. Because you could theoretically, try to tell it that I want it to be where the city is equal to the address, which wouldn't make sense here, but that's not what we're doing. We're actually pulling a string. Now, if we use numbers, we don't need to actually add those single quotation marks. We can just add the number. And by not adding the quotations, we're telling that this is a number, and we're looking for a number in our database. And so there are also other data types that I kind of haven't added here. Oh, excuse me. There's also dates, which if you're practicing with dates, you want to make sure you surround those with quotation marks. There's also floats, which are similar to numbers, but they have like a decimal place and then a tenth place and a hundredth place and so on and so forth. Floats also don't need quotation marks. And also here, what we did is we use the equal sign, but there's also several different types of operators that you can use. Down here, we use the not equal to. This is the not equal to sign in SQL. And then kind of as you may have guessed, greater than or equal to is kind of what you would think it would be. And I think it's the same as is what it is in Excel. Yeah, Matt.
Quick question for when you're adding in different things, I'm going to say where we are in city Berlin and the postal code is not equal to this. I don't know if that actually makes sense. What's the operator that you use to combine?
Yeah, that's actually a great segue into our next slide, which is the and statement. Because obviously, as Matt just alluded to, sometimes you don't only want to pull one, or you don't only want to filter by one condition, but you actually want to filter by more than one. And if you have two criteria that you want to meet, then you would use this and statement, which is essentially kind of an extension of where. So rather than doing where and then another where, you do and. And in this case, we're building upon what we did earlier. Previously, we just had where the city is equal to Mexico DF, but now we're going to also do it where the postal code, which is another column here, is equal to 05021. Essentially, maybe we only wanted people in this city who meet this postal code criteria. And now, rather than pulling both customer records that belong to the city, we're only finding the one from the correct city and the correct postal code. And if you wanted to go on from here and continue to add in criteria, you would just use more and statements. And you can continue to add and statements to your heart's desire, as long as there's more conditions to be added. But on the flip side of that, we can do an or. So rather than us wanting to meet both conditions, maybe we're only okay with meeting one or the other. So it's a very similar syntax to the previous slide where we were reviewing and, But this time we have an or statement, and I've actually changed the postal code here. So this is actually a different number. And this postal code actually refers now to this first customer record for a customer who has who's in Berlin. And now what we're saying is we either want them to live in Mexico or have their contact address be Mexico DF, or have this postal code which happens to belong to Berlin. And so the SQL code will go through each of these records and find the instances that meet either one or both of these requirements. And as you can see here, it pulled these two customer records. Okay, so now let's give it another shot, and we'll take another like 5 minutes here, and then I'll show you the examples once more. So what we're going to do is we're going to first pull the name of all products that has a price level less than 5. So you already had a bit of a shot to try out that products table before. And next, what we're going to do is we're going to find the name of all customers who live in Germany and have a postal code that is less than 5,000. So this gives you a shot to try it out with more than one condition being met. So take a few minutes to try that out, and then once again, I'll run through the solution, and we'll continue barreling forward. Hey, yeah, what's up, Matt?
Is there a quick way to like comment out like a specific request? So I've got like a multi-tiered request I'm going to dive into, a couple different characteristics. Within that, I'm like, hey, I'm not really sure what I'm going to ask for in terms of like postal code. Is there a way, like in R, I could just put a hash in front of it and it comments it out?
There definitely is. For some reason, I can't remember what it is.
There we go.
But I'm just gonna.
Can you come here?
Yeah, I think you can just put a double dash. Like
the double dash.
Yeah.
Yeah, and something that I kind of like touch on later, as a kind of like a final note at the end is that you're not going to remember everything, and there's going to be things that you need to do that you haven't been able to try before. But if you search it on Google, you'll find the answer in like 2 seconds. Not like I'm always happy to answer questions, but I think that's like probably the most important like thing you can take away when from this is you're not the first person to have these questions. Cool. Just another minute or so. Okay. So let's give this a shot. So the first thing that we're doing is we're pulling the name of all
Hey.
products.
Kevin, we can't see your SQL screen.
Oh yeah, sorry. I was just shifting it over here so I can give it a look. Okay, now you can see, right?
Yep, good. Thank you.
Cool. So pulling all the name of the products, I guess that have a price less than 5. So we're here on the products table. So so let's kind of organize ourselves here. And so what we're trying to do is we're trying to find the name of all the products. So the first thing we want to pull is from here, product name. Great. And then we want to find all products that have a price less than 5. So we don't actually, to do this, we don't actually need to have price be its own column in the output. But I think it's nice to have in order to kind of verify your output. And where are we doing this from? We're doing it from the products table. And here's the part that we're now adding, where the price is less than 5. And we run this and we get these 2 items right here. And yeah, that's it. So the second part is find the name of all customers who live in Germany and have a postal code less than 5,000. So now we're moving off of this products table and we need to figure out how to find customer information, kind of intuiting it, probably in the customers table. So what are we trying to find? The name of all customers. Okay, so we want to find the name of all the customers. So probably what we want is this customer name here. Great. Who live in Germany. Okay, so we want to see their country. Great. And have a postal code less than 5,000. Okay, postal code, and that's this column. And once again, all you really needed was the customer name, but I just like to show these. Where are we pulling it from? It already entered it for us here, the customers table. And now we add our where statements, where country equals, and since this is a string, we add our quotations, our single quotations, or equals Germany. Great. And then we have a second condition, and postal code is less than 5,000. And we didn't need to add any single quotations since this is a number. We run the SQL and we get the output right here. So any questions on that?
Yeah, it showed us 12,000. One of the postal codes was 12,209.
Oh, that's true. Oh, that's a great question. Why is it doing that?
Yeah, I'm also getting a data type mismatch and criteria expression.
What is it saying?
That's all it says. It says data type. It says error in SQL, data type mismatch and criteria expression.
Well, I wonder what is going on there.
Is that partly because like you have the UK postcodes where it's like a mixture of numbers and letters, so it has to be uniformly put in text?
Yeah, that might be it. It might be that these are actually strings. So I might have given you a bad example, and my apologies for that.
Yeah, no point. Karin just brought it up, so.
Yeah, that I didn't realize that these are actually because of what you just referenced, that these might actually be strings. But at least, I don't know, at least I guess it worked on the orders, and we saw that when we did it with the orders, the price of the products, this was undoubtedly a number. So sorry for giving you kind of a bad example of that. I guess I should have vetted that a little bit more. But I guess, that's a good example of why it's always nice to kind of have the columns that you're pulling a condition from in the output, because we were able to identify that looking at the output. So I guess an unintended lesson was taught there. All right, but let's keep going. Okay. So now that we kind of went through that, now we're going to look at the order by statement, which is the last statement that we're going to go over today. So sometimes you want to make sure your output is actually organized in a certain way so that it's easy for you to read when you get the output. So what you do here is you actually can have a new statement on the end, which is the last statement, which is order by. And what we want to order by is we want to order it by the customer name. And how we want to order it is descending. And so when we talk about a string, that is going to be ordered alphabetically. So when we have descending, we actually start from the end and work our way back to back forward. So we start with Z and go back to A. And you can see here in the output that the customer name is reverse alphabetical. And actually we can, if we wanted to, we could order by several different types of attributes. So we could also add a comma and do then order by country. And what it would do in that situation is it would first organize by customer name and then by country. It wouldn't matter in this case, whoops, because there's only one record for each within the customer name. But let's assume there was two Tom's specialization, and one was in Germany, and then the other was in the UK. It would first order it by the customer names, and then within the two Toms, it would then order it by country. You can also order numbers. So we saw here in the last example that postal code was not actually a number in our database, it's actually a string. But let's assume for a second that postal code is actually a number. We could also order numbers in ordering them ascending means that it goes from 0 to infinity. Whereas if we did it by descending, it would go from infinity down to 0 and then down to negative numbers. So the logical kind of flow of a number. Cool. Now we can kind of get into some of the math functions. So this is kind of what I was referencing earlier when we can extract information from using SQL. Earlier, kind of what we've been doing is we've been just kind of filtering down from the database and getting an output that's like a filtered down version of that. But sometimes we want to answer like specific questions, like what is the most expensive thing that we sell? And while you could easily just pull all of the product names, export it into Excel and figure it out in Excel, you can also ask SQL to do the same thing and save yourself some time. And we have these useful functions to help us do that. So on the left-hand side, the first thing that we have, the first kind of math expression is max. And you can see here that price was our column name. And so we're still in the select statement referencing a column, but we're putting it within this these brackets, which are our function. And that's similar to how kind of Excel does functions as well, where you have a function within the brackets is kind of like the conditions. It works similar in SQL. So here, what we're finding is the max price. So we're asking the question, what's the most expensive product we have? And we get the output here. It gives us the column name max price, which is what we entered here. and it tells us what product that was. So here we can see what our most expensive product in the catalog was. Okay, on the right-hand side, we're still using max, and then obviously, as you might have been able to assume, we can do minimum. But what we're literally doing here is we're putting in a subtraction sign, a minus sign, and we're just subtracting the max price from the minimum price. And so the question that we might be asking here is, what is the difference between our most expensive product and our cheapest product? And here we have our output. We can see that the difference is 261. And there's all different sites of math operations that you can do. You can do obviously the ones that you would expect: plus, minus, divide, division. But there's countless beyond that. And so, we don't have really the ability to go over all of them here. But once again, if you need to do something, you can quickly search it and find it on the web. You're not the first person to have these questions. And I guess one other thing, yeah.
Oops. Got a question from Allie in the chat. She asks, is max price a column in the database?
No, that's a great question. So the max price is not a column. The column is price. Max is a function. And so I can we can kind of quickly go over, we can kind of see that for ourselves. So if we go back here and we go back to our products, we can see that here's the price. And what we're doing is we're just selecting the max price. And it's going to go through each of these, and it's going to find the highest number. And when we run that, it gives us the highest number. And we don't really need to, and that's just essentially what it's doing. And it returns this column named max price because that's what we told it here. But this is kind of a little bit cumbersome. So we can always go rename it. And I can go as highest price, and that we can rename it, and then I can name that column whatever I want. So that's another useful tip for you, is to use as to rename it as whatever you want, so it can, when you're presenting your data, it's nice and clear. Hopefully that answered that question. If not, we can continue to clarify that. Okay. And while we're not going to be able to go over each of the different math functions and functions within Excel, a couple useful ones are to count. So right here, we're counting the customer names. Oh, whoops. So how many customers are within the database? It's 11. We can also use another function, sum. What's the sum of the total prices? It's 200, and we can see what is the total price. If you purchase each product in our catalog, how much would it be? And one other thing to show is here, what we were showing is we were counting the customers' names to find out how many customers we had. And this table is actually really nice because no customers are actually duplicated. But it's definitely, in some tables, you'll have maybe you'll have duplicate customers' names. So maybe there's Island Trading, and then there's another Island Trading. And they're not necessarily, they're the same company. It's just there happen to be two different records in our table. And so if that was the case, and we were selecting, we wanted to count the customers, customer Siri. If we wanted to count the customer name, we might be counting duplicates. And so you can always count distinct. And in this case, it'll only find the distinct instances. So in this case, it was the same number because there's no duplicates. But I guarantee you in most of the databases that you work with, that won't be the case. And like I said, there's countless other functions that you can use. There's no way we can go over them all here. But if you search for them, you will find them online, and you'll find examples of people's other code that they've used it, and you'll be able to kind of like learn how to use SQL better that way. So let's go into our final exercise. So we have 3 things here. And how many orders were shipped using shipper 3? What was the average quantity of items in an order? And what was the largest quantity of items in a single order? And how much larger is it than the average order quantity? So let's take like 5 minutes until like 11:27. Then we'll go through the solution, and then I'll wrap it up, and we should be able to get out of here by 11:30. All right, just another 30 seconds or so. Okay, let's jump into it. So flip screens again. Wait a second. Okay. So the first thing that we were doing is how many orders were shipped using shipping 3. So what we can find here is there's a column called shippers, but that's not really what we want. We can actually find it here in orders, and we can find here that there's actually shipper ID here in orders. So what we're going to do is we're going to select count, and we're going to count and what's useful here is the order ID. And order ID is almost certainly like the unique identifier, but it's always kind of like a really good practice to add distinct just to make sure you're not double counting. And so now we're here, we're counting only the number of orders. And where are we doing it from? We're doing it from the orders table. And now we actually have to filter down on where, and what we have here is shipper ID equals 3. And if we run that, we get 68. And one thing to point out, shipper ID equals the 3. What the hell does that even mean? But we do have a shippers table where we can see shipper 3 equal federal shipping, which is actually a useful piece of information. And we could have done it where, how many orders were shipped using federal shipping. But for that, we would need to use joins, which is what we'll be doing in the next class. So just kind of a preview of things to come. All right. What was the average quantity of items in an order? So we're using the orders table again, and we are selecting the average quantity of items in an order. So where was that? Oh, here we go.
I found it under order details.
Order details, yeah, thank you. There we go. So we have the quantity there in order details. So we are selecting, we're using the function average and finding the quantity from the order details, from the order details table. And simple enough, it gives us an average of 24.6. All right, our final and kind of more complex one was what was the largest quantity of orders in a single order and how much larger was it than the average? So if we restore this, so what was the largest quantity of items in a single order? So we're using the same one, and now we want to use the max quantity. And this is just the first part of it. We can see what that max quantity was. And we can see here it's 120. The other part of that was the average. We could also run that separately, right? But the easier way, and then we could, calculate each of those separately and then do the math ourselves. But, the foolproof way of doing that is just doing 2 functions and then finding, and then letting SQL actually calculate the output for you. And so there we go. My answer is 95.4. Any questions on that last example? All right, if not, I'm gonna wrap it up then. So for our final tip, I've kind of referenced this a couple of times, but if you don't know how to do something, just Google it. Like, I can't emphasize that enough. I have yet to have a question that didn't have an somebody else ask it with an example and a solution on Stack Overflow. And it's always at the top of your Google search results. So that should be, Google search should be your help buddy, your first help buddy. But, also feel free to reach out anytime to me if you have kind of more nuanced questions. Always happy to help out. And kind of the pitch for the next class is we're going to be learning how to do the joins. So we kind of referenced this a couple of times and showed how joins would be super, super powerful and useful. So, if you enjoyed this, stick around for next time so we can answer questions like how many orders did customers from Germany place? And that's all I've got for you today. So thank you all for showing up, trying out the examples and staying for the entire time. I will be here for as long as people have questions they want to ask. But if you are done, feel free to log off and have a great weekend.
Oh, please fill out the post-event survey. I see people rapidly leaving.
Oh, sorry.
This will definitely help us. If you liked it today, please let us know what you did or didn't like so that we can plan better for next time and also future programming for both clubs.
I have a question, Kevin.
Yeah, what's up?
I know like we are teaching some basics of SQL in this series of events. I'm wondering, will we talk about like how we can better present ourselves to the future employer in terms of the SQL skills level? Like, I mean, how I can prove that I have the ability to do SQL task?
I feel like that's just gonna, I don't know what the best way to show your employer that you're like good at SQL. For me, like I just straight up on my like resume or CV just say that like I think like advanced in SQL. But I know there's also like certain like certification courses that you can take. Like I think like LinkedIn has like maybe a skills course that you can take and show that you passed that and are proficient. But that would be, I guess, my recommendation.
Okay, thank you.
Yeah.
Will we do a cornerstone project in the last session of this event?
Yeah, that's a great question. I actually don't think we've answered that question. I don't think we've made that decision yet. There's actually going to be kind of, for each of the different parts of the series, we're going to have a different person kind of leading the charge, but we've been coordinating together. But I think you have a really good suggestion there. I think it's something worth doing.
All right, look forward to the next event. Thank you so much.
Yeah, thank you for coming.
Hey, Kevin, I have a question. I have a really specific question. Is there like a contact information I can email you or anything?
Yeah, I can put that into the chat. If I can find the chat, I'll just put it in. So I just posted my email into the chat. So.
Okay, great, thank you. I also work at Amazon and I'm working on Redshift right now and I'm trying to create a script and it's not really going the way I wanted, so I wanted your help.
Yeah, sure.
Okay, thank you.
Of course.
All right, I'm gonna stop the recording.
Yeah, I think we've done it.